Polar bears and polar cubs, let's talk about Charles's Law. So, very similar to Boyle's Law, with the fact that it has to do with volume, but this time we're going to swap out pressure and we're going to talk about temperature. A huge step is making sure that you have converted temperature into Kelvin. If it is not in Kelvin, you will not get a right answer. So please make sure that you are converting temperature to Kelvin first thing when you start one of these problems. They are directly related, which means if one goes up, the other goes up, or if one goes down, the other goes down, meaning they're going to do the same thing. So let's walk through one of these problems, and then I'll have you guys do the second example on your own. So we have a T1 of 25 degrees Celsius, a V1 of 752 milliliters, and a T2 of 50 degrees Celsius. So first thing, let's make sure that we get those into Celsius by adding into Kelvin by adding 273. So we have 298 Kelvin. T2 then is going to be 323 Kelvin with a V1 of 752. Since we're solving for V2, it's going to be V1 T2 equals T1 V2. So divide each side by T1 and then plug in our values. 752 goes up top times 323 divided by 298. Here's where we can do a little quick check. Our temperature increased, so the temperature on the top should be bigger than the temperature on the bottom. 323 is bigger than 298. Multiply it, you're going to get 815 milliliters. And that's a Charles's Law example. I'm going to scroll down. I'm going to have you guys do this one on your notes on your own, and we'll go over the answer here shortly. 3, 2, and 1. So we have a V1 of 500 milliliters. That decimal is very important. It tells you that you have 3 sig figs there. But then we're told that, hey, T2 is 100 degrees Celsius. That gives us 373 Kelvin. And for V2, we have 850. Again, with a decimal place, meaning it's 3 sig figs. Plug it in and solve for T1. So we have V1 T2 equals T1 V2. Divide each side by V2. And we're going to get 500 times 373 all over 850. Now, you might go, the temperature went up, so our volume should go. Our volume went up, so our temperature should go up. But since this one is asking for T1, what we should really notice is that since we have our higher temperature, our temperature should be much lower than what it originally was. And when you multiply this, you get 219 Kelvin. And 219 compared to 373 is a big jump. If you were ever asked to find it in Celsius, all you'd have to do is then subtract 273 from it. This is going to give you a negative 54 degrees Celsius. And that is a very large jump from 100 degrees Celsius to negative 54, or vice versa. And then if you were going to look at the relationship graph of them as temperature and volume go up, so it just looks like a nice linear equation. All right, best of luck, and a big reminder, sig figs.